All right. In this video, we're going to talk about the chemical equations and what kind of information they give you. Before we can talk about balancing equations, before we can talk about predicting products, we have to know what types of equations there are and what they tell us. Okay, this is different from the types of reactions in the last video, but this is types of actual equations. And there's three types. Okay, and the first type are word equations. No numbers, no letters, they're just words, okay? So it describes in words only the identities of the substances in a chemical equation or a chemical reaction. Okay, so example, hydrogen plus oxygen yields water. I don't tell you how much hydrogen, I don't tell you how much oxygen, I don't tell you how much water, I don't tell you what state they're in. I just tell you we get hydrogen and we got oxygen and we get water. Okay, so a real world example would be like if I told you to go into the kitchen and bake a cake. Get flour, get eggs, get milk, mix all that stuff together, some other things, of course, but and you'll get a cake. I'm not telling you how much, I'm not telling you what kind, I'm just telling you that's what you need and you'll get a cake. All right, so it's pretty hard to figure out everything with just a word equation. Second type, you've got your skeleton equation. Okay, and each one of these is going to give you more and more information. So your skeleton equation, this tells identity, formulas. So in the last one, we just gave you the words and the names, and now we're actually going to give you the formulas. Of those substances. Okay, so if we're keeping with the water example, now you've got H2 plus O2 yields H2O. So we're getting a little bit more exact. I'm telling you now you need not only do you need flour, but you need all-purpose flour for your cake. You know, not only do you need milk, you need 2% milk or whole milk or whatever. So I'm actually telling you a little bit more about what type of things you need to make this cake. Still, the problem is I'm not telling you how much of each one of these you need. So that comes in our last type, a full-on chemical equation. And in a chemical equation, you have the identities, formulas, relative amounts of each formula. Okay, so now our example, our water example, we have H2 plus O2, and what we need are coefficients. Okay, and that's going to tell us exactly how much. So now I've told you you need, 3 cups of all-purpose flour. You need, half a cup of milk. You need 3 eggs. Now I'm telling you the exact amount of everything you need to make this cake. I'm telling you the exact amount of each hydrogen, each oxygen that you need to get water. Okay, so those are the different types. So let's look at not a complex reaction, but one that has everything in it. And let's talk about what they are. So in this equation, we're going to blow this up a little bit. You have 2H2. That's a G in parentheses, plus O2, and again, a G in parentheses, and we're going to talk about what that means, and an arrow, and you have 2H2O. And then this is a lowercase cursive L in parentheses. Okay, so let's talk about what all of these are. All right. First of all, we need to know that everything on the left side of the arrow, those are our reactants. Okay, everything on the right, that's our products. Okay, so we have our products and our reactants. Okay, probably one other thing I need to add. I'm going to add a triangle above the arrow. Okay, we'll talk about what that is. So you have your reactants on the left and you have your products on the right. All right. The big numbers that go in front, those are your coefficients. All right, and a coefficient tells you the number of compounds, okay, or the number of molecules that you're dealing with. Here, it says we have 2 hydrogen molecules, okay? The little number, one there, those are called subscripts. Those tell you the number of atoms. Okay, so if we were to only look at the left side here, okay, if we were to only look at the left side and we were to draw this, we have H2. Okay, so let's say we have H2, but then here it says we have 2 of them, so we need to draw a second one for a total of 4 hydrogen atoms. So you're going to take the coefficient and multiply it by the subscript to get the total number of hydrogen atoms. Okay, and then over here we have oxygen, and there's 2 of them there. So your oxygen molecule, now there's no coefficient here in front, so it's understood to be a 1, a lot like math. Okay, so over here on the left side we have 4 hydrogens and we have 2 oxygens. Okay, then when you go over here and you make 2 waters, okay, for each water, looks like that, and then your coefficient of 2 tells you you've got 2 of them. Okay, so in a true balanced equation, you have the same number of hydrogens and oxygens on the left as you do on the right. So if we counted these 1, 2, 3, 4 hydrogens, you have 1, 2, 3, 4 hydrogens on the right as well. You have 2 oxygens on the left, 1, 2, and 2 oxygens on the right, 1, 2. Okay, so it is balanced. All right. So that's how you work with coefficients and subscripts. The next thing that we're looking at is the arrow. Okay, this arrow does not mean equals. Okay, it means yields or reacts to produce. Okay, do not say hydrogen plus oxygen equals water. It does not equal water. It yields water. It reacts to produce water. Okay, so that's the arrow. Also, you can have an arrow that looks like this. Okay, and that just means that it is a reversible reaction. Okay, so if we had one in this case, not only would hydrogen and oxygen react to give you water, but it could also reverse itself and say that water can decompose into hydrogen and oxygen. Okay, so there are reactions out there that can go both ways at any point. So the last thing, or sorry, not the last thing, the next thing, this right here is a catalyst. So a catalyst, and we'll talk about what a catalyst is later, but the catalyst is written above the arrow, all right? And your triangle here, more specifically, represents heat, okay? So a triangle represents heat, but anything above and the arrow is a catalyst. So it could be a formula, it could be a symbol, anything above the arrow is a catalyst, okay? So the last thing, we'll do this in a different color so we can get, you know, a little bit more colorful, I guess. The lowercase l, lowercase g, those are states of matter. Okay, so G equals a gas. So in this case, we have hydrogen gas and oxygen gas. S means solid, lowercase l, and we use a lowercase cursive l so we don't confuse it with a 1, although we should never put a 1. That's why we use that. That's a liquid, so we get liquid water out of this. Okay, and the last one is AQ. Okay, and AQ just means that it is an aqueous solution. Some people call it aqueous, some people say aqueous. It doesn't really matter which. All it means is that it has been mixed with water. Okay, so when you look at an equation, that's all the information you can gather from it. Okay, and that's what everything means. So from here on out, you should be able to see a chemical reaction and be able to identify its parts.